Hey guys, welcome back to the continuation of organic chemistry. This is the topic which is called saturation test. Before a saturation test, we were dealing with the basics of alkenes and we were dealing with the basics of alkanes. Some of the reactions of alkanes have been studied as well. Right now, I'm going to teach you what is a saturation test. Okay. Guys, there are two types of the compounds which we have studied till now. One of them is called as alkane and the other is alkene. Okay. Now we are going to check which one of them is saturated and which one of them is unsaturated. Let me inform you before dealing the details that this compound, which is called alkanes, are saturated hydrocarbons. Saturated hydrocarbons, whereas alkenes are called unsaturated hydrocarbons. All right. Now we are going to check this thing that how we can say that any compound is a saturated hydrocarbon or any compound is unsaturated hydrocarbon depending upon the position of the double bond, depending upon the presence of the double bond. Rightly saying, if a compound has a double bond in it, it is called as unsaturated. Double bond means a carbon-carbon double bond. It is considered as an unsaturated hydrocarbon. Okay, guys, let me give you one example. For example, there is one compound and this is like this, okay, and this is like this. For example, this is here, for example, this is here, for example, this is here as well. For example, there is one OH over there as well. Okay, now we can see this thing. I am not writing the hydrogens. Okay, you can see this thing. For example, this carbon has made how many bonds already? Two bonds, so it is going to make two more bonds. You already know this thing that carbon is a part of group number 4. So when it is a part of group number 4, it is going to make four covalent bonds. These four covalent bonds can be considered as three covalent bonds on one side, that is called as a triple covalent bond, and the one bond on the other side, or the four separate single covalent bonds, or the two double bonds on each of the side, or one has a double bond on one side and the two separate single covalent bonds in addition to that. Okay, so there can be any possibility. Now here we can see this thing that this carbon atom has made two bonds, two single covalent bonds. So it is requiring two more hydrogen atoms. Okay, so I'm writing two here. You can check this thing as well. This carbon atom has made one single covalent bond here and the other single covalent bond here. So it is deficient of two more bonds. So I am writing H2 over here. OMG. Now we are on the next one. This carbon atom has already made four covalent bonds. One is this, two are there, and one is this as well. So overall, four covalent bonds are already there. So we are not going to write any hydrogen in it. Okay, let's consider this compound as an example of finding saturation or unsaturation. Okay, guys, there is no carbon-carbon double bond. There is a carbon-oxygen double bond. It is not considered as carbon-carbon double covalent bond. That's why this compound will be considered as saturated hydrocarbon. It is not a unsaturated compound. It is not an unsaturated compound. It is considered as a saturated compound. Why? Because it does not have any carbon-carbon double covalent bond. Rather, it has carbon-oxygen double covalent bond. So I am repeating my words back to the original thing that those compounds which have carbon-carbon double covalent bond are considered as unsaturated hydrocarbons, whereas those which have no carbon-carbon double covalent bond, they are considered as saturated hydrocarbons. Let's have few examples on the next page. Okay. I am on this page right now. I am just telling you a few examples here. You can check this thing. It will elaborate the idea. It will explain the whole thing. Okay, guys, now for example, 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Okay. Now, for example, in a compound, there is only one double covalent bond. Okay. In B compound, there are two double covalent bonds. In the C compound, there is a triple covalent bond. Okay. In the D compound, there is no covalent bond. Okay. No double covalent bond. Okay. I am mentioning it over here as well. This is C and this is D here. Okay, guys, you can check this thing. You can check this point. You can check this point and this point as well. You can check this point as well. Okay, and you can check this as well. There is no double covalent bond here or triple covalent bond. Okay, guys, A will be considered as all of them. Before explaining the A, I would like to inform you that all A, B, C, and D have seven bonds. Okay, seven carbon atom chain. You may say it is a carbon atom chain of seven carbon atoms. All right. Now, can we say this thing that A has a double covalent bond, carbon carbon double covalent bond, that is shifting that compound into the category of unsaturated hydrocarbons? Okay, hydrocarbons, guys, I'm bringing your attention back to this point. Hydrocarbons are those compounds which are made up of carbon and hydrogen. Here I am not writing the hydrogen, but I'm supposing this thing that you already know this thing, that where to place hydrogen. To give you a reminder, to give you a revision of this concept, I'm going to write the hydrogens with the first one. For example, the first one has the first carbon. Okay, it has made only one bond here. Okay, so it is going to make three more bonds. So here I'm going to write H3. What about the second one? It has made three bonds already, so it is going to make one bond here. And for example, what about the third one? It has already made three bonds, so it is going to make one more bond. What about the next one? It is having two bonds already, so it is going to make two more bonds. So in this way, it is going to make two, it is also going to make two, whereas this will make three covalent bonds with three hydrogen atoms separately, because it has already made one single covalent bond with the previously present carbon atom. Okay, so now we can check this thing that number A is considered as an unsaturated hydrocarbon. Why it is so? Because it has a carbon carbon double covalent bond. What about the number B? Oh, it has two carbon carbon double bonds. So definitely it is considered as an unsaturated hydrocarbon. What about the C? There is a new thing. And what is that new thing? Guys, this is called carbon carbon triple covalent bond. So whenever there is carbon carbon double covalent bond, or whenever there is carbon carbon triple covalent bond, it is considered as an unsaturated hydrocarbon. Okay, okay. I will give you few examples, few reactions, few explanations related to this as well, so that things may be on the very clearer note. Okay. If I'm talking about the D part right now, D compound, can you look at this compound? It has a seven carbon atom chain, and all of them are attached with each other through a single covalent bond. So can we say this thing that all of them have no carbon carbon double covalent bond, have no carbon carbon triple covalent bond? That's why A is considered as a saturated hydrocarbon. So out of all these four, we can say that A, B, and C are considered as unsaturated, whereas D is considered as saturated hydrocarbon. Okay. Now, guys, there is one more point, that how we are going to detect that a hydrocarbon is saturated or unsaturated. There is one test which is called as unsaturation test or saturation test, or to detect saturation or unsaturation. It is to react the compound with liquid Br2, or you may say bromine solution, bromine water. Okay, bromine water or bromine solution, or it can be simple bromine as well. So many words can be used, or examiner can use many words. Okay, now guys, we already know this thing that bromine has a color, and what is that color? That is red brown in color. Okay, red brown in color. Okay, now I am telling you that if, for example, saturated hydrocarbon, saturated means carbon carbon single bond, saturated hydrocarbon is there. Okay, and we are going to react it with liquid Br2. So it is written like this. I am writing here, after the reaction, what will happen? No color change. No color change is observed. No color change. Okay. Now I am telling you about the next one, that is unsaturated. Okay. Unsaturated hydrocarbon. it is going to react with a carbon-carbon double covalently bonded compound. And what is going to react? The same thing that is called as liquid Br2. As a result, what will happen? A color change, color change, or you may say color of liquid Br2 will undergo a change. Okay, color of liquid color of liquid Br2 will undergo a change. Is that okay right now? So we can say this thing. What is a change? It will turn blue. What is the change? It will turn black. What is the change? It will turn white. No. So we are just telling that change means that the color of liquid Br2 will be lightened in the same shade. So we may say it is lightened to light yellow, it is lightened to light orange, it is lightened to very light yellow, lime color, you may say it is lightened to colorless, for example. So there are different degrees of discoloration. There are different degrees in which the color has been decreased. Okay, the level of color, the intensity of color is decreasing basically. Okay, if the color is not changing, if the intensity of the color remains same, it means that it is a saturated hydrocarbon. And if the compound is unsaturated, definitely there will be a color change. Okay, up to which level there is a color change? Do we need to tell the exact color change? No, there is no need to tell the exact color change. You may tell this thing only, that unsaturated hydrocarbon decolorizes the liquid Br2. Okay, decolorizes the liquid Br2. That color will not be there. Okay, and it is going to decrease in the same shade with lesser intensity. Okay, I am telling it to you here. Unsaturated hydrocarbons are decreasing the intensity of the color of liquid Br2. So color of liquid Br2 decreases. The intensity of the color is decreasing. Okay. So this is the basic point about which you should know. Okay. Now, for example, I am just telling you here that what will be the color change. So we are going to take this compound, and this compound is made up of, let's say, 4 carbon atoms. I'm writing here, it is H2 here, it is H3, sorry, it is H3 here, it is H2 here, it is 1H here, and it is H3 here. Guys, now it is going to react with Br2. And here it is, we are going to write the L thing, that is symbolizing that it is a liquid in the state. Okay, what will happen after the reaction? Just consider the same. It is same carbon atom chain, but double bond will be shifted into the single covalent bond. This is one of the important point which you should need to notice, and which you should keep this in your mind as well. Okay, the remaining hydrogen atoms will be remain as it is. Okay, now where these two Brs are going? These two Brs are going to attach. One more problem is there, it is 2 here. Okay, and it is 2 here as well. So it is 2. Okay, so I am writing Br here and 1 Br here. So guys, can you look at this right now? This double covalent bond thingy is now going to convert into single covalent bond, and it is now going to attach the two Brs along with this. Guys, this is one of the type of the addition reactions. Addition reactions are those reactions in which there are two reactants which are going to react with each other to make one product. So you can check this thing, that this is one reactant, this is another reactant, whereas only one product is being produced. Okay, don't forget this thing, that what is the category of this compound? This category, the product which is being produced, is called as halogenoalkane or haloalkane. What is a haloalkane or a halogenoalkane? It is an alkane having attachment or having halogens as a part of it as well. Okay, so this is called halogenoalkane. Halogenoalkane. Is that okay right now? So this is how we are going to find this thing, that after reaction with liquid Br2, we can say this thing that a halogenoalkane is produced. Is that clear now? If there is still a confusion or a query, I'm going to explain it further, so don't get upset on it. Okay, I'm going to change the board. Okay, you can check this thing that there are different types of the compounds. All of them are double bonded compounds. So number one is this. This is number one, 3 and 4 and 5. Okay, out of this there is only one double bond. We are going to react it with Br2. As a result of that, what is going to be produced? 1, 2, 3, 4, 5. Guys, you can check this thing that I have shifted the double covalent bond into the single covalent bond. Here deliberately I am taking the different color so that you people may have an idea that it will be remain same. Guys, I should write the number of hydrogens at the top as well. It is H3. It is 1H here, it is 1H here, it is H2 here, it is H3 here. I'm going to write the same number of hydrogens with the products as well. So it is H3 here, it is H here, it is H here, it is H2 here, and it is H3 here. Okay. So what is at the top? That is called an alkene. So this is an alkene. Whereas what about this? What is the product? So it is a halogenoalkane. These are the perfect name. These are the specified name. These are the fixed name for this. No, I am just telling you the generic name, the class name of these compound. That the top one is a part of the alkenes. The bottom one is a part of the halogenoalkanes. But these are not the specified names. These are not the fixed names for these compounds. So here I'm telling you halogenoalkane. Halogenoalkane. Okay, let me inform you one more thing, that in case of an alkane and halogenoalkanes, what is the difference? Alkanes are the compounds which don't have any halogen in it, whereas halogenoalkane or haloalkanes are the alkanes which have the halogens attached with them as well. So this is the difference between the two. You people are going to keep the difference in your mind very clearly. Okay, now you can check this thing, that what will be the color change. We can say this thing that initial color of liquid Br2 was red brown, but after the reaction the color is changed, or you may say this thing that color is changed to light yellow, for example. Okay, now I am going to give you another example. This is compound A. Let's suppose there is another compound, and that is compound B. Okay, in this example I am going to take number of carbon equal to the number of carbons of A compound. So both of them have 5 carbon atoms. But guys, here I'm going to take the double bond at 2 position. At number 1 carbon atom, carbon number 1 has a double bond as well, whereas carbon number 4 and 5 have a double bond between them between the two as well. Okay. Now I'm going to write down the hydrogen atoms. It will have 2 hydrogen atoms. It will have 1, it will have 2, it will have 1, whereas this will have 2 hydrogen atoms with it. Okay, now I'm going to react it with Br2. You can check this thing. This is Br2. After the reaction, what is going to be produced? You can check. It is carbon number 1, carbon number 2, 3, 4, and 5. The 2 carbon atoms which have the double bond, both of them will be shifted into the single covalent bond. It means that we are requiring 4 BRs as a result. Okay, 4 BR are basically required. So instead of Br2 only, we are going to write 2 Br2. 1 Br2 means how many BRs are there? 2 BRs. 2 Br2 means how many BRs are there? 4 BRs. 3 Br2 means how many BRs are there? 6 BRs. Okay, so just keep that thing in your mind. Guys, I have told you when I was teaching you the chapter of element compound mixture and atomic structure thingy, at that time I have told you that there are different types of the elements depending upon the number of atoms being attached in that. One are called as the monoatomic elements, those all which are part of elements of group number 8, and those all which are metals are considered as monoatomic elements, and those all which are part of group number 7 are called as halogens, which are diatomic elements. In addition to elements of group number 7, oxygen, nitrogen, and hydrogen are diatomic as well. So we may repeat that statement which we have done already many times. What is that statement? All the elements of group number 7, oxygen, nitrogen, and hydrogen, are naturally diatomic. So if you're going to write the formula for oxygen, you're going to write O2. For hydrogen, you're going to write H2. For nitrogen, you're going to write N2. For chlorine, you're going to write Cl2, etc., etc. In the same way, all the elements which are part of group number 7, or they are diatomic, and all the elements of group number 8, along with the elements which are metals, are monoatomic. So you're writing silver, you're going to write Ag only. You're going to write sodium, you're going to write Na only. So this is how we are going to differentiate. There is a third category as well, and that is called as polyatomic elements. So those elements which are made up of, which are consisting of more than two atoms of that element together. For example, sulfur, S8, for example, phosphorus, P4, for example, oxygen, O3, ozone. Okay, so oxygen has two forms. We have studied the allotropic thingy already. Okay, you may go to that video in which you may just write down the word of allotrop. You will find that video over there on my channel. Okay, you can see this thing. This is a compound which has double covalent bond. I'm back to B now. Okay, so here I'm writing H2, here I'm writing H, here I'm writing H2, here I'm writing H, here I'm writing H2. So first of all, I have written the whole thing as it is. Now I'm going to place the Br. So you can check this thing. All the double bonded carbon atoms are now single bonded carbon atoms. So this is Br and this is Br. My God, yes, there is a huge difference between A and B. What is that huge difference? Both of them are made up of five carbon atoms. This is five carbon atoms as well. You can check this thing that in this case, only one double covalent bond, whereas in the bottom one, the B1, it has two double covalent bonds in it. Okay. You can check this thing that in the A thing, the one double covalent bond is changing into the single covalent bond, whereas in the B, the two double covalent bonds are changing into the single covalent bonds very clearly. We one more thing which we know this, which we should know from this example, that what is the color change in A and what is the color change in B? Do they share the same color change? Do they show the same color change? No. What is the color change in A? As there is only one double covalent bond, so it is going to show the color change that is to the light yellow, you may say, or light orange, you may say. What is the color change in the B? You may say colorless, you may say very light yellow. It means that the second one, this B has a more number of double covalent bonds. We will say the degree of unsaturation is higher in B, whereas degree of unsaturation is lesser in A. Okay. So A is unsaturated. How we know this thing? Because it has a carbon-carbon double bond, one carbon-carbon double bond. B is unsaturated. Yes, we agree. Why? Because it has two double bonds, two carbon-carbon double covalent bonds. But we have to say this thing that B has higher degree of unsaturation as it has higher number of double covalent bonds. When it will have higher number of double covalent bonds, it means it will have greater ability to discharge, to decolorize the color of liquid Br2. Whereas this one, number one, A, will have the lesser ability, will definitely have the ability to decolorize the color of liquid Br2, but A will have the lesser ability to decolorize the color of liquid Br2. So this is how we are going to differentiate between the two compounds having unsaturation. But we will say this thing, the one which will have higher number of double covalent bonds will have higher degree of unsaturation. I'm going to write it on this page. Okay. A hydrocarbon having higher number of carbon-carbon double covalent bond has higher degree of unsaturation. Higher degree of unsaturation means what? Higher will be the color change with liquid Br2. Higher level of discoloration. Okay. Higher level of decolorization, you may say. Okay, so these are the points which you guys should keep in your mind, that what is the color change and how the degree of unsaturation is affecting the color change. Higher the degree of color, the higher the degree of unsaturation, higher is the color change. Lesser the degree of unsaturation, lesser will be the color change. No unsaturation, no color change. Okay, so this is how we can tell about the color change. I have told you, first of all, the double covalent bond will be changed into the single covalent bond. If there is one double covalent bond, it is requiring one Br2. If there are two double covalent bonds, it is requiring two Br2s, etc. Okay. Guys, one more thing which I would like to bring your attention over there. You can check this, for example. Okay. In this case, we can see this thing that this is a hydrocarbon and it is an alkene. How we know it is an alkene? Because it has a carbon-carbon double covalent bond. Okay. Now, for example, examiner is saying that this is compound A, okay, and there is one more compound and it is compound B, okay. And examiner is giving you another compound like the same number of carbon atoms, but it has higher degree of unsaturation. Why it is so? Because A has 5 carbon atoms and one double covalent bond. B has 5 carbon atoms but two covalent bonds. So A has lesser degree of unsaturation, whereas B has higher degree of unsaturation. In A, examiner is going to react it with hydrogen. In B, examiner is going to react with hydrogen as well. In A, examiner is saying that 100 centimeter cube of hydrogen is passed through this and 100 centimeter cube of hydrogen is passed through this as well. Okay. So after the reaction, what will be the product? So it is C and C, C and these five as well. Okay. So guys, here I'm writing the number of hydrogen. First of all, it is 3, it is 1, it is 1, it is 2, and it is 3. I'm going to write the same number of hydrogens here as well, just to shift the double covalent bond into the single covalent bond, and the added hydrogens will be written with another color so that you people may differentiate. Okay. I would like to take, yes, a very clear change. Okay, so these are the two hydrogen atoms which are being attached here, and as a result the double covalent bond is shifted into the single covalent bond. Here I am writing the same thing, and here I am writing this is 1, 2, 3, 4, 5, and don't forget to write the hydrogen atoms here 2, here 1, here 2, here 1, and here 2. I am going to write the same number of hydrogens here as well. It is 2 here, it is 1 here, it is 2 here, it is 1 here, and it is 3 here. And what about the hydrogen atoms which are being added? I'm going to write them with the green color, the parrot green color, so that you people may be able to check this very clearly. This is 2 here actually. Okay, so you can check this thing. It is one hydrogen here and the second hydrogen here. Guys, can you check this thing that this is the double covalent bond which is now shifted into the into the single covalent bond. So that's why the two carbon atoms of this double covalent bond are now attaching the new hydrogen atoms as well. Okay, so this is the difference you need to know. Okay, then the two more carbon atoms which had the hydrogen atoms already are now going to attach the newly coming hydrogen atoms as well. Okay, so that I am mentioning over here as well. You can check this thing that this has a double covalent bond shifting into the single covalent bond and the two hydrogen atoms as well. This has a double covalent bond shifting into the single covalent bond and have the new hydrogens as well. This had the double covalent bond and finally it is going to shift itself into the single covalent bond, and as a result the two hydrogen atoms are being attached with the same two carbon atoms which have the double covalent bond. Guys, one more thing which is very very important. I have observed this thing that when students are writing this type of the answers, they go with the flow of their emotions and mashallah, what's not. Okay, and what they are going to write, they have a little bit idea, but that little bit idea can create bigger problems. Okay, so what is that? They are doing this type of the questions when and at that time they are writing hydrogens with these carbon atoms which are already sufficient of hydrogens. They are not requiring any additional hydrogens. Look, this carbon atom has a bond, this carbon atom has a bond with one carbon atom and the three hydrogens atom as well. Guys, I'm repeating my words again and again again and again that each of the carbon atom cannot make more than 4 bonds. So when a carbon atom does not have a double covalent bond, it is already attached with the hydrogen atoms or with any other element. So it is not going to add anything further. Okay. So only the double bonded carbon atoms are going to convert themselves into the single bonds. Okay. So guys, now examiner is asking that hydrogen is passed through A, 100 centimeter cube of hydrogen is passed through A, and 100 centimeter cube of hydrogen is pass through B as well, which will give more hydrogen after the reaction. Okay, guys, you can check this thing that this compound, this A compound has one carbon double covalent bond, whereas B compound has two carbon double covalent bonds. It is just telling you that A has lesser degree of unsaturation, whereas B has higher degree of unsaturation. So for example, if there is A option, okay, I am just writing the options that A option is saying, I am just rubbing the labels here. Instead of saying it A and B, I would like to say it X and Y. A option is saying that this will be the option, for example. Okay. Okay. I should write it like this. Okay. And this is Y. Okay. So this is A, this is B, this is C, this is the D. Okay. So it is B, it is C, it is D option. Okay. Examiner is saying I have to reduce the pen size as well. Okay. I'm writing with the red color now. So examiner is saying that X will release like 80 centimeter cube. Okay. Here B option I'm writing, whereas Y will release 60 centimeter cube. X is in A, he is saying that X is going to release 30 centimeter cube, whereas Y will release 50 centimeter cube. C is saying that both of them are 80 centimeter cubes, and D is saying that both of them are going to release, let's suppose, you may consider one is releasing 80 centimeter cube, whereas the other is releasing, this is, you may say, in case this 70 centimeter cube. All right. Oh, 70 is not a good option. You may consider 90 centimeter cube. Okay. So guys, which one is the right option? Let me inform you very clearly. The right option for this question is B. Okay. Why it is so? Guys, A, the X, the one which is X now. Okay. The X has 100 centimeter cube. X will use only 20 centimeter cube as it has lesser degree of unsaturation. Y has consumed more hydrogen and it has consumed 40 centimeter cube, and after that 60 centimeter cube will be left. Okay, so E, A, B, C, D are the options which are telling this much hydrogen is released. C will be wrong option. Why? Because both of them cannot release same volume of hydrogen after the reaction. And D is wrong as well, because in D, X is releasing lesser hydrogen, whereas X should release more hydrogen. And D is wrong because Y is releasing more volume of hydrogen, because Y should release lesser volume of hydrogen. Same is happening with A as well. A is wrong. A should be opposite basically. A should be opposite and D should be opposite as well. Guys, it is just telling you that in case of this X, you can check this thing. In case of this X, it is having only one carbon double covalent bond. That's why it is consuming lesser volume of hydrogen to convert that double covalent bond into the single covalent bond. Whereas in Y, there are two double covalent bonds. That's why it is consuming more volume of hydrogen atoms. So after the reaction, when examiner is going to measure the volume released after the reaction, which volume of hydrogen will be released from X and what volume of hydrogen will be released from Y. So he will have this observation, he should have this observation that X is consuming lesser volume of hydrogen, whereas Y is consuming greater volume of hydrogen. Okay. Guys, I would like to bring your attention to one question as well in the next video. And here I am just mentioning that what will be the start of our next video. It is from one of the past paper question, and that is passage of hydrogen through different oils. Examiner has given different oils. We can consider any name of the oil, different oils, and identification of degree of unsaturation. Okay, so this will be our next heading. We will check this thing that how this is going to affect the degree of unsaturation. We will check this thing that how the hydrogen can be used to check the degree of unsaturation through different oils. Okay, so passage of hydrogen through different oils. Okay, oils. Oils means vegetable oil, almond oil, coconut oil, palm oil, seed oil, etc., etc. Okay, so we will pass the hydrogen through them, and we will check this thing that which one of them has the highest degree of unsaturation. Through this past paper question, we are going to start the next lecture. Thank you very much, all of you. May you all get a good grade in chemistry, inshallah. Take care of yourself.